This lesson will describe how the solubility of different solutes varies. Varying solubility can be caused by a number of factors. A few of the factors could be how well attracted ions are to water molecules. Recall that water molecules are highly polar. The polar attraction of water molecules for specific ions can vary based on the type of ion. If we look at the trend for potassium iodide in the curve below, we can see that as the temperature increases, the solubility of the chemical potassium iodide also increases. The solubility is described as the number of grams of solute dissolved in 100 grams of water. Looking at a temperature of approximately 10 degrees, we can see that the solubility of potassium iodide, or Ki, is about 135 grams in 1 gram of water. As the temperature rises, say to 25 degrees, the solubility rises also to approximately 150 grams of solute per 100 grams of water. The curve, or the trend line, is what we know as the solubility curve, and it shows the relationship between temperature and the solubility of a particular solvent. You can see in most cases the curves rise. This generally indicates that with increases in temperature, most solutes dissolve more mass as the temperature increases. When looking at the curves, you do see that some of the curves do fall instead of rising. This would be typical of what would happen with a gas. The solubility of gases tends to decrease as the temperature rises, allowing the gas molecules to escape the water more easily as the particles move around more rapidly. What the curve can tell us is what the saturation point is for any particular solute at a particular temperature. Let us take the temperature of 80 degrees. At 80 degrees, when comparing sodium chloride, NaCl, it appears approximately 40 grams of solute of NaCl would dissolve in 100 grams of water. However, if we looked at KCl, or potassium chloride, by looking at the graph, approximately 52 to 53 grams of potassium chloride dissolves as a result of it being a different particle or a different solute. Continuing upward, NH4Cl, or ammonium chloride, at 80 degrees has a saturation value of about 67 grams of solute for every 100 grams of water. Therefore, the saturation points for each of these particular solutes vary, even though they are at the same temperature. What would the saturation point of potassium nitrate, or KNO3, be at 60 degrees when looking at the curve? In order to answer this, find 60 degrees and follow the line upwards till it crosses the graph for KNO3. Read across on the scale to determine the saturation point of KNO3 at 60 degrees. The saturation point at 60 degrees for this chemical, KNO3, would be 110 grams of solute for every 100 grams of water. Let us find the saturation point of sodium nitrate, NaNO3, at 40 degrees. Again, locate the point on the graph for the temperature, 40 degrees, and follow the trend upward till it crosses the solute of interest, NaNO3, or sodium nitrate. Read across to follow and locate the saturation point for this particular chemical. You can see the saturation point is approximately 103 grams of solute for every 100 grams of solvent. Therefore, if any amount less than 103 grams has dissolved in a solution at 40 degrees, the solution would be considered unsaturated at that point. However, it would be saturated as soon as we reach the value of 103 grams at 40 degrees. Let us look at some questions that allow us to more deeply understand solubility curves. In this example, we're interested in the saturation point for potassium iodide at 15 degrees. Therefore, we find 15 degrees on the graph, and we draw a line upwards until 15 degrees crosses the solute of interest. We can see it crosses the point for Ki somewhere at approximately 140 grams of solute. Therefore, 140 grams of solute would be dissolved when the solution is at 15 degrees if we're speaking of the chemical called potassium iodide. In this particular question, they'd like to know how much more sodium nitrate is possible to be dissolved. This means that the solution is at an unsaturated state, meaning there is still room to dissolve more solute. A similar strategy would be employed as to the previous example. First, find 50 degrees on the graph and draw a line upward till it crosses the chemical of interest, in this case potassium nitrate. What this will reveal is the saturation point for potassium nitrate at this temperature. We can see that the saturation point is somewhere around 83 grams. When reading the problem, they say that only 75 grams was dissolved. This therefore means there is an unsaturated solution and still room for more dissolving to occur. By simple difference, we can see that there's room for 8 more grams of solute called potassium nitrate to dissolve at this particular temperature of 50 degrees. Let us take a look at another similar example. We see when reading this example that the solute known as potassium chloride is now the solute of interest. Therefore, we will look on the curve for the temperature that we are interested in for KCl, or potassium chloride, drawing a line upward from 90 degrees till it crosses KCl, and then reading across on the graph the approximate point to reveal the saturated value. The saturated value at 90 degrees would be 53 grams of KCl. However, in the words it says that only 32 grams of KCl has been dissolved. Therefore, by simple difference, we can see that the solution is not yet at the saturated state. Or we could say it is unsaturated. Therefore, there is room for 21 more grams of KCl to dissolve because it is in an unsaturated state at this temperature. When reading this question, the key idea is the term here, unsaturated. This means that there is still room for more dissolved solute at the specific temperature. Therefore, we're looking for unsaturated conditions for any of the solutes possible on the curve. By drawing the trend line upward from 80 degrees, we can determine this. From 60 degrees. Let's draw the trend line upward from 60 degrees to reveal where it crosses each of the curves. What we now look for is we look for the amount of solute that is possible to dissolve at this particular temperature. When looking at SO2, approximately 5 grams of solute would create a saturated condition. Therefore, SO2 would not be unsaturated if 80 grams were dissolved. Drawing a second line will be useful in this case. The second line for the condition of 80 degrees running all the way across will reveal what we're interested in. Any solute that intersects the line at 60 degrees that is above the green line of 80 degrees, these intersections indicate an unsaturated condition. Therefore, in this case, sodium nitrate, potassium nitrate, and potassium iodide would each be unsaturated if 80 grams of solute were dissolved at 60 degrees temperature. We can see when we look at KNO3, somewhere approximately 110 degrees could possibly be dissolved. Similarly, when looking at sodium nitrate, NaNO3, somewhere approximately 125 grams could be dissolved. if only 80 grams were dissolved, these would certainly be unsaturated solutions. Similarly, Ki, the solubility is so good that it really doesn't even appear on the curve, and it would be well above the trend with the maximum value of 150 degrees on our curve. Let us maybe look at one more question to practice the idea of saturated versus unsaturated using curve data. When reading this question, we're now interested in the saturation point for a specific chemical when 40 grams of the solute is dissolved at 75 degrees. Let us draw an upward line from 75 degrees till it crosses. We can see there are two chemicals that would have a saturation point very similar, with 40 grams of solute dissolving in 100 grams of water. The two chemicals in this case would be sodium chloride and potassium chlorate, NaCl, KClO3. Each of these would be saturated when 40 grams of solute is dissolved at a temperature of 75 degrees of solution. Recall, the condition of saturated means the maximum amount dissolved at a specific temperature. Conversely, the condition of unsaturated simply means there is room to dissolve more solute and has not quite reached saturation yet.